Now what we went over yesterday was changing logarithmics into exponentials and exponentials into logarithmics. So log base b of x is equal to y. We can rewrite it as b to the y is equal to x. And we went over exactly how we switch from one form to the other. Yes, and we kind of felt comfortable with that. Probably didn't make a whole lot of sense why it worked that way, but that's what we did. Now, by the end of the lesson, this will actually make a little more sense. Now, by definition of a logarithm, it follows that the logarithmic function g of x is equal to b log base b of x. Its inverse of the exponential function is b to the x. That means if I take log base b of b to the x, it will give me x. They will undo each other. It also follows that b to the log base b of x will equal x. So really what we can say is that these functions undo each other. So if the base and whatever's inside the log are the same, they cancel each other out. If we put the logarithm to its base, they cancel each other out. Does that kind of make sense how this works? So using this here, when we talked about log base b of x is equal to y, because this was our function and we switched it to exponential yesterday, yes? Well, that means if I put this b to the log base b of x, well, anything we do to one side we have to do to the other. Well, this log base b to the log base b of x, the log base b in that b would simplify out. Would we agree with that? Which really on the left-hand side would leave me with just, would just leave me with x. Yes? Well, what's left on the other side? B to the y, whatever that base is. Well, isn't that what we were doing yesterday when we were switching those from one to the other? This is why. This is why this works. It's not that we just magically switch it. It's because really we could apply, if we're given log base b of x equals y, put both sides to the b to those powers, and they would simplify. The same is true going the other way around. Because if I start off with this here, if I want to get this exponent out or rewrite it, we can put both sides to the log base b. Well, this one side would end up just being log base b of x is equal to, well, these cancel, leaving me with just y. So that's really the function behind how we can switch from one to the other. So let's look at these here. So we have 10 to the log of 4. Well, what would this be? But what is our base with this logarithm? It would just be 4 because the base is 10. This is what we call a common log. Whenever the base for a log, log, is not written, it is understood to be 10. So these will simplify out, leaving us with just 4. Now this one here, we just can't say x because we have log base 5 of 25 to the x. Can I rewrite 25 as 5? It would be what? 5. Because 25 is the same as 5 squared to the x. Running out of room. You can put it to the side also. You don't have to write it below. Because really what's inside this log, when we have 5 squared to the x, powers of powers, to multiply. So we'd have 5 to the 2x. And this so here would simplify to what? To just 2x. because log base 5 of 5 simplifies to 1. So if we're good with this here, let's look at these next two here. Log 10 to the log of 18 would be 18. Now for log base 4 of 16 to the x, well, we can't just simplify it out. We need to rewrite 16 as 4 to a power. And this would be what? 4 second, because 4 squared is 16. Well, really, this is the same as saying log base 4 of 4 to the 2x, which would be but that's it for those there. Any questions on any of these here? We ready for the next ones? How about 8 to the log base 8 of x? What would that be? It'd just be x. So number 14 is log base 7 of 7 to the negative 3x. Okay. 15. I think you also have a little more space than I do. I'm going to write it down here. You can write it below. Number 15 in your notes, because you do have a little more space than I do. I also have a filing cabinet in the way. So we really want 64 to be 2 to a power, because that'd be nice. So we can go through and do the multiples of 2. Well, 2 squared is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is... So it would be 2 to the 6th power. So we could rewrite this as log base 2 of 2 to the 6x, which simplifies to 6x. All right. Last one that we have, e to the ln of 20 would be what? 20. Because what is the base for our natural logs? It is. It's always e. The base for any natural log is e. Questions on these here? Find the inverse of each function. So we'll look at these in different ways. But let's look at this first one here. F of x equals 6 to the x. Well, we can rewrite f of x as y is equal to 6x. Then we switch x and y, because we did these last chapter. X is equal to 6 to the y, yes? Now, how can we get the y by itself? Well, we can't divide the 6. Is there a method that we've been doing that's really kind of rearranged the numbers, more or less? Or logarithms, haven't they? Because if we do kind of I'm going to write one method out to the side and I'll do a different method down below, okay? Now, the way that we did this yesterday, if I wanted to rewrite it as a logarithmic, I would say log base what? Of is equal to, so our f inverse of x is log base 6 of x. And that would be the inverse function. Any questions on this here so far? Let's give it up now. And I'm going to pull up the graphing calculator so that we can see this. Now, move this over to the side. Now, we just said log, when the base and what's inside the logarithm match up, they simplify out, yes? So the other way that we could do this, besides just using the switch method, is that I could apply log base 6 to both sides. Because over here, log base 6 of 6 simplifies out and leaves us with just, not x. Bless you. Bless you. Yeah, it should be y. Log base 6 of 6 to the y. It's going to get the y by itself. And what I have left over is log base 6 of x, which would tell us that it is our inverse. So really, when we do that kind of switch method and applying log base 6 to both sides, we're doing the same thing. We're just not explicitly writing this out when we do the switch. Questions on this here? Okay. To do the switch or write it out? So our original function was 6 to the x. That was our original exponential function. Clear? Math. Log base 6 of x. And when we dealt with logarithms or inverses, we said they always were reflected across the line y equals x. Yes? So if we look at these two graphs, they're still reflected across that line. They are inverses. So an exponential function's inverse is the logarithmic function. Now this graph, the one in red, it's hard to see, but it will continue straight down. It will never cross the y-axis because it doesn't have a negative value. We cannot have negatives inside the logarithms. It just won't work. So questions on this here? So we do have another type because we do have 2 on this page. I have to erase this. And we have y equals ln of x. Now they already wrote y in, so first thing we need to do is just switch them. You don't have to rewrite it. So we can say x is equal to ln of y plus 3. So at this point here, we can do either our switch or we can put both sides to the e, because either way is going to give us the same result. So if I put both sides to the e, e to the x is not going to simplify out. That's just going to be e to the x. But e and our ln will cancel because the base and what we're putting it to match up, leaving us with just y plus 3. What do we need to do next? Which would tell us that y is equal to? And that's it. That's all we need to do for this here. Any questions on any of this here? I moved this one over because I realized we wouldn't have a lot of space with it down there. It's down there in your notes. I'm going to fix it later. So we'll do these last two, and then y'all can get where you're needing to go, because I feel like y'all are getting the hang of this. It's not too bad. So we look at A, f of x equals 11 to the x. Well, we can really say y is equal to 11 to the x, because f of x is the same as y. And then we can switch the x and y. Is equal to y. I just like putting y, whatever we're solving for, at the end on the left side. F inverse of x, yes. Now, the homework on big ideas, you will have some of these here. It's just going to say y equals. It's going to want you to type this in. So yes. Then we would use f inverse because we started out with f of x. That's our answer. Any questions on any of this here? So the last one that we're going to look at is this here. Well, they already wrote it as y equals the natural log of x plus 6. So we can go on in, switch the x and y. Yes. E to the x is equal to. And that's it. Now we could have other functions, like instead of having the natural log of y plus 6, we could have the natural log of y, just the natural log of y, plus 6 on the outside. And we could get that function. Are there any questions on this here? So what I'm talking about is having something like, we could have something like this here, and we can find its inverse. But to do that, well, we would first switch. And this isn't on here. You can kind of watch this if you want. We would really move the 6 first, which would give us x minus 6 is equal to the natural log of y. And then we're going to put both sides to the e. So the x minus 6, since it's on that side, would be all clumped together. It would be grouped together, which would really tell us that e to the x minus 6 is equal to y. So we could have other operations. So we could have some numbers being multiplied by the log and different types like that there. Any questions on this here? So it didn't add too much. It's just manipulating the numbers. Do we feel comfortable with these here? And that